Module 5, Introduction to Nanomaterials. The main objective of studying this unit is to understand the concept of nanotechnology, its origin, application, and how this upcoming technology can lead the future engineering. The term nano originates from the Greek word and it means dwarf. 1 nanometer is 10 raised to minus 9 meter or 1 billionth of a meter. To compare the size of materials, nanoscale is used. An ant is 5 millimeter in size, red blood cells are 8 micrometers in size, viruses are 50 to 100 nanometers in size. Nanomaterials are a set of substances where at least one dimension is less than 100 nanometer. Nanomaterials are intermediate in size between that of isolated atoms or molecules and bulk materials. How small is nano? To understand how small is the nanoparticles, there is a scale given. So in the scale, water molecules is zero point 0.1 nanometer. Glucose molecules are 1 nanometer. Virus is 100 nanometer. A bacterium is 1000 nanometer. And a cancer cell is 10 raised to 4 nanometer. And the tip of the pencil is 10 raised to 6 nanometer. And a tennis ball is 10 raised to 8 nanometer in size. In this scale, we are particularly interested in the 1 to 100 nanometer size particles, and it includes fullerenes, carbon nanotubes, nanoparticles, antibodies, etc. To understand how small is nano, an example is like if you take 1 teaspoon of paint, that will be sufficient to cover 1 nanometer thickness a football ground completely. History of nanomaterials. Nanotechnology appears to be a modern technology, but its existence was there from ancient times. Greeks and Romans used sulfide nanocrystals to dye their hair 2000 years ago. Golden nanoparticles are used to produce different colors in stained glass windows 1000 years ago. In 1959, the first concept discussed by renowned physicist Richard Feynman in his talk, There is Plenty of Rooms at the Bottom. With this talk, the nanomaterial revolution started. In 1974, the term nanotechnology was introduced by a Japanese scientist, Norio Taniguchi. In 1981, IBM developed scanning tunneling microscope. With the invention of the scanning tunneling microscope, they could able to find the smaller particles like buckyball, that is C60, and carbon nanotube. Nanoscience and nanotechnology. So if we take a 1 centimeter cube material and make it into smaller particles of 1 nanometer cube size, the surface area will increase enormously. As the surface area increases, surface energy also will be increasing. So crushing a particle into nanoparticle size increases the surface area enormously. And the properties of the materials are also will be entirely different when compared to the bulk material. So to study about nanoscience and nanotechnology, it demands new tools and new understanding. Nanoscience is the study of structures and materials on the scale of nanometers. Nanotechnology is the design, characterization, production, and application of structures and devices in a nanometer scale. What makes technology at the nanoscale different from technology at the macro scale is, as the particle size decreases, Greater proportions of atoms are found at the surface compared to those inside. As objects get smaller, they have a much greater surface area to volume ratio. Properties of nanomaterials. So here it is shown bulk gold. It is yellow in color. But if you go to nano gold, the color of the gold will change from yellow to ruby red. The properties of the materials are distinct at the nano level due to increased surface area and quantum confinement effect. Nanomaterials have properties that are different from those of bulk materials that depends on the crystal structure, shape, and size of the nanomaterials. Nanotechnology is an interdisciplinary subject related to physics, chemistry, material science, information technology, biology, biotechnology, medicine, and engineering. How do scientists work on such a tiny scale of materials? Now we have sophisticated microscopes known as scanning probe microscopes. So with the help of this scanning probe microscope, we are able to see the nanoparticles also. A scanning probe microscope uses an extremely fine probe tape and it runs over the surface feeling for contours and shapes. Examples for scanning probe microscope includes atomic force microscope, scanning tunneling microscope, etc. Making nanomaterials. So to make nanomaterials, there are two approaches. One is called as the top-down approach and one more is called as the bottom-up approach. Nowadays, the computers and phones are getting smaller and more powerful. So to make this smaller and more powerful electronic devices, it demands more smaller and smaller components. So we can make these smaller components either by the top down or by the bottom up approach. Nano from nature. Nature is the best manufacturer of nanomaterials and nanostructures. Biomimicry is the term scientists copying from nature. Lotus leaves are having a self-cleaning property and butterflies are having different colors due to light absorption and scattering of light by nanoparticles. Nanotechnology is already in our lives. Nanoelectronics has enabled the miniaturization of electronic gadgets in our daily life. And in sports, tennis balls becomes more bouncy and tennis rackets are made more stronger with the help of nanomaterials. And soaps that can contain antibacterial nanoparticles of silver will keep our feet healthy and odor-free. Textiles made with hydrophobic liquid repellent nanostructures will help to keep them stain resistant and water resistant. Cosmetics and sunscreens containing nanoparticles will protect the skin and will give more comfort. Applications of nanotechnology. Nanotechnology can be used in all fields, including from energy, medicine and drugs, nanobiotechnology, nanodevices, optical engineering, defense and security, bioengineering, cosmetics, and nanofabrics. One of the main application of nanotechnology is in computers. The silicon transistors in your computers are replaced by carbon nanotubes now. So due to the use of carbon nanotubes, the size of the microprocessor is reduced to a greater extent. And the advantages of using carbon nanotubes are the size of the computers becomes smaller and it becomes more faster. And it will use only less energy. Nanotechnology can be used in medicine also, and the uses includes in drug delivery, cancer treatment, surgery, tissue engineering, and visualization. And it can be also used in antimicrobial techniques for nanoparticle creams, nanocapsules, cell repairs using nanorobots. Nanotechnology can be used also in food processing, food by making food products, nutrition, agriculture, and nanofoods. Advances for the future using nanotechnology is it makes nano products more lighter, stronger, faster, smaller, durable, precise, and less expensive. By seeing that, we can say that almost all branches of engineering, from right electronics, medicine to robotics, will be nanotechnology based in the future because of its efficiency, durability, reliability, and reproducibility. So nanotechnology will be the future engineering.